introduced just a descriptive statistics case where we talked about the variance, and we said that when we have to report the measure in the original units, then afterwards another measure is very useful, and we introduce the notion of a standard deviation in that case. Similarly, we are going to introduce the measure of a standard deviation of a random variable. So I can define the standard deviation of a random variable as a square root of the variance of a random variable, and this quantity is called the standard deviation of x. In other words, it is just the positive square root of the variance, and like the expected value. Now, if I have a random variable, the expected value of the random variable would take a units, and since this is the variance of square root of the variance of x, the standard deviation of the random variable and the expected value have the same units, or they are measured in same units. Now, let's again look at properties of the standard deviation. So again, what we are interested in knowing is, I already have the following. If x is a random variable and c is a constant, expectation of c times x is c into expectation of x. The variance is c square variance of x. Now, expectation of x plus c is expectation of x plus c. This is just variance of x. This is something which we have already seen. So, now let's see what happens to the standard deviation of x. I know the standard deviation of x is given by SD of x. So, now I know that SD of x is square root of variance of x. So, what would SD of Cx be? SD of Cx is going to be variance, square root of variance of x. Cx, I know variance of Cx is c square variance of x. So, this is going to be c into root variance of x. I know root variance of x is standard deviation of x. So, standard deviation of Cx is c times standard deviation of x. That is my first property. That is standard deviation of a constant multiple of a random variable is constant multiple into c d of x. So, I can write here this is c into standard deviation of x. The next thing which we need to see is what happens to standard deviation of x plus c. This is going to be root of variance of x plus c, which was same as root of variance of x, because variance of x plus c is same as root of variance of x, which is standard deviation of x. So, I have standard deviation of x plus c is standard deviation of x, and I can complete the table by writing standard deviation of x here. Okay. Now, this is very useful. These properties are very useful for me to compute certain formula. So, now let's look at an example where I am interested in knowing the following. So, if variance of x is 4, what is standard deviation of 3x? Now, if variance of x is equal to 4, I know standard deviation of x is equal to 2, which is the same as root of variance of x. Now, if standard deviation of x is 2, then I apply standard deviation of c times x. C is equal to 3 here, is 3 times standard deviation of x, which gives me 3 into 2, which is equal to 6, and hence the answer is 6. Now, there is another way we can do it. If variance of x equal to 4, I know variance of 3 times x is 9 into variance of x, which is equal to 36. Hence, standard deviation of 3 times x is going to be square root of 36, which is equal to 6. Both of them give you the same answer. Now let's look at the second question. Variance of 2x plus 3. I know variance of 2x plus 3. Applying my formula is 4 times variance of x. Now this is given to be 16, which gives me the variance of x is equal to 4. Hence standard deviation of x is equal to 2. So standard deviation of x is equal to 2 if variance of 2x plus 3 equal to 16. Now let's look at a few applications of standard deviation. Remember, standard deviation takes the same units as that of the expected value. Recall we talked about Sanjay and Anita, who were two people. Now assume that they are a married couple. That is, I define a family, they are a married couple. This is how I am defining it. They work for the same company. Now I am giving Anita's bonus as a random variable. I know the expected value and standard deviation of Anita's bonus. So let x be Anita's bonus. It is a random variable and bonus. X is a random variable. Given that expectation of x is rupees 15,000, it takes the values, and standard deviation of x also takes the same value. It is rupee 3,000. Now let y be Sanjay's bonus. What is given to us is expectation of y is 20,000 and standard deviation, again it takes the same units as 4,000 rupees. Again, I am assuming earnings of Sanjay and Anita are independent of each other. This implies that x and y are independent random variables. That earnings of Sanjay and Anita are independent of each other. So, if I have the bonus, they are independent of each other. Hence, x and y are independent random variables. This is an assumption. I want to know what is the expected value and standard deviation of the total family bonus. By family, I am just assuming Sanjay and Anita form a family. So, my total family bonus is going to be x plus y is my total family bonus. I want to know what is expectation of x plus y, and I want to know what is standard deviation of x plus y. X and y are any random variable. We know expectation of x plus y is expectation of x plus expectation of y. That is the sum. Expectation of sum is sum of expectation. Hence, expected value of the total family bonus is going to be 15,000 plus 20,000, which is going to give me a rupees 35,000. Now, to compute the standard deviation of x plus y, I know the variance of x is going to be 9. Variance of y is variance of x plus y is 25, which will give me the standard deviation of x plus y is square root of variance of x plus variance of y, which is about 5,000 rupees. Hence, I have computed the expected value and standard deviation of the total family income. Now, let's look at another application, which is lawyer's fee. Suppose I have a lawyer who has to decide about two options. The first option of the lawyer is charge a fixed fees. Whether I win or lose, if I am the lawyer, I am going to just charge a fixed fee. And what is my fixed fee? It is 25,000 rupees. Okay. And the second option, this is option 1. The second option is I am going to gamble. So here I say that I can either win or lose. I assume I can win and lose with equal probability. I say that you pay me, but you pay me 50,000 if I win. You don't have to pay me anything if I lose. Okay. So the question is option 1 or option 2 favorable to me if I am a lawyer? So let's look at the expected value in both the cases. Now here, if X is my earning when I am charging a fixed fee, X is taking one value which is 25,000 with probability 1. Hence, expectation of X is rupees 25,000. Now, Y takes the value 50,000 with probability half, 0 with probability half. Expectation of Y is again rupees 25,000. So, if only expected value was of concern to me, then both the options return the same expected value, namely 25,000 rupees. But there is a risk. Whereas option 1 always gives me 25,000 surely, whether I win or lose. Here option 2 gives me a high return if I win and I could lose money. So I lose money. That is, I don't get anything at all if I lose. So there's a risk of me not getting anything at all. The expected value does not reflect this risk. So how can I compute that? Now let's look at the standard deviation of the X values. Standard deviation of X and standard deviation of Y. X takes only one value, hence the standard deviation here is equal to 0. Whereas when I look at standard deviation of Y, Y takes the value 50,000 and 0 with equal probabilities. I can check that the standard deviation of Y is equal to 25,000. So you can see that whereas here, if in a sense I am measuring the risk of me losing money with standard deviation, then I can see that this option 2 has a much higher risk than option 1. Though in expectation, both of them returned the same value. Hence, the notion of standard deviation plays an important role in applications of this kind, where you want to measure in addition to expected value or the average, you want to have a measure of dispersion. Dispersion can measure volatility or spread or risk in some way. I'm loosely defining these terms, but I just want you to give an idea of where you could use measures of standard deviation and how that can help you or aid you in decision making. So if you are a person for whom this risk is important, then you might just go with option A. But if you are a person who feels that it is okay to take this level of risk, then option B is a better option for you because you have a chance of getting 25,000 extra, which is you get 50,000 rupees. So in summary, what we have learned so far is the notion of a standard deviation of a random variable. We looked at again properties of the standard deviation. Namely, we saw that standard deviation of C times X is C into standard deviation of X, and standard deviation of X plus C is standard deviation of X itself. And we looked at how to apply concepts of standard deviation to answer certain real-time applications. With this, our discussion on general discrete random variable is complete. The next thing which we are going to look at is a very special and specific random variable which is called the binomial distribution. So again we will start by looking at where are instances where a binomial distribution makes sense? We look at the expectation and the variance of a binomial random variable, and we look at a lot of applications wherein the random variable can be modeled as a binomial random variable, and how we can use that information to reach to conclusions. Thank you.